Okay, the second part of this section 9.4 is dealing with word problems and applications of vectors. So there's really only about 3 different types of problems in this lesson. I'm going to do one of each, and then there are 2 that I'm going to leave blank, and I do need you to do those. So please, 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 when I say try this one, it's going to be numbers 2 and 4. Please do try those 2 on your own, okay? So I'll come around and check those in class. All right, first thing. We have number 1. Andrew Zandomenico is pushing Luke Myers in a wheelbarrow up a ramp of 25 degrees at Chipotle. Okay, so when you're doing these, obviously they should be making triangles here. So if you can picture a ramp, 90-degree angle with the ground, okay? And this one says a 25-degree ramp. So the 25 degrees is going in here with the ground. Okay, now it says he's pushing with a force of 75 pounds. Now, I'm not going to get into a ton of physics in any of this lesson or the next couple lessons, but the force, that 75 pounds, is going to go on the ramp. So on the slanted part, on the hypotenuse. And every year students say newtons and all these kind of things. No, we're not going to get into any of that. So the 75 pounds just goes on the hypotenuse. And then the problem says, express the force vector in component form, meaning give me the horizontal and the vertical components. So we're going to break a slanted force on the hypotenuse into its horizontal x values and its vertical y values. So if you forget the fact that it's a word problem, we're really just coming down to SOHCAHTOA. Now, please make sure your calculator is in degree mode. That's really important because it's probably still in radians. And let's start with x. So if I say SOHCAHTOA, cosine of the 25 degrees is adjacent over hypotenuse. All I'm really doing now is multiplying that 75 up to the top, and then I'm already ready to grab that calculator. So if I break that up into the horizontal component and I crank that in the calculator in degree mode, I get 68.0. Okay? Now, if I do the same thing with the y value, let's go to sine now. Sine 25 is y over 75. Exact same thing, and I get y to be 31.7. Again, check that mode. So then the final answer for this type of question, we want to write the final answer as a force. So now I'm going to write the force is, okay, so horizontal first, 68.0. And then remember, this gets your i's. And then 31.7, that gets your j's. So I split the force into its horizontal and vertical components. All right, not a whole lot of magic to that one. Okay, so again, please do try number 2. It's almost identical, so it should go very quickly. Do not leave that one blank. Okay, now the next example is kind of the same idea where you're breaking a slanted force into its vertical and horizontal components, only this time I'm going to give you 2 different forces, and then in part C of this question, I'm going to ask you to add them together. Okay, so let's just take a look at this one. 2 forces of magnitude 30 and 70. Okay, so the forces, again, are going to be the hypotenuses. And on an object at angles of 45 and 120 degrees with a positive x-axis. So there's nothing about that that needs to worry you. You're just going to draw your angles. So let's do the first one first. So the 30 Newton one will go with the 45 degrees. Okay, so 45 degrees would be in the first quadrant, 45 degrees. Okay, 30 newtons goes on the hypotenuse. And again, let's not get all physicsy. We don't need to break anything down with the newtons. And then if I want to do F1, force 1, in component form, well, I can just drop my right triangle there. And this would be a non-calculator question since it is a 45, 45, 90. And so with the n root 2 idea, this guy over here should be 15 root 2. And so should this one, 15 root 2. Okay, so I'm going to write this down in part C because I'm kind of running out of room here. So force 1 in component form would be 15 root 2 i's plus 15 root 2 j's. Okay, now let's do the same thing with force 2. All right, this time it's a 70 newtons at a 120. So we're going to treat 120 the way we always have. It's going to come over here in the second quadrant. It will have a 60-degree reference angle. And if it's 70 newtons on the hypotenuse, we're going to deal with this like a 30, 60, 90. So the one across from the 30 should be half the hypotenuse, so it'll be 35. And again, it's negative second quadrant. And then the one across on the 60 should be 35 root 3s. Okay, so then my force 2 in component form would be negative 35i's plus 35 root 3 j's. Okay, so now I have two components, two vectors, both in component form, two forces. And now what I want part C is I actually want to know what happens when I add them together. So it's as simple as combining like terms. So if I want to know F1 plus F2, you're going to combine your horizontals. So here are my horizontals, right? And since they're not really like terms, you have a root 2 and a non-root 2, we're just going to kind of clean it up and write 15 root 2 minus 35. And then we'll just put our I on the outside of that one. And then if I do the same thing with the vertical components, it would be 15 root 2 plus 35 root 3, and then I'll sneak my J on the outside. Now, number 4 is almost identical, so please, please, please try that one on your own. All right, now the last type of question in this lesson has a lot to do with physics, but we are not going to attack the physics side of things, okay? So if I just read it as it is, we're going to start building a picture here in a second. A weight of 800 pounds is suspended from 2 cables. Okay, so we're going to think there's a horizontal beam up here, and the weight of 800 pounds is going to be suspended down. Okay, and the 2 cables make 35-degree and 50-degree angles with the beam. So 35-degree and 50-degree with the beam. Doesn't matter which one's which. And wants to know what are the tensions on the 2 cables. So tension 1, tension 2. What are those numbers? Okay, now, when I draw my 800, technically it would kind of go straight down to the center of the earth kind of thing. But we're going to take what we call a parallelogram approach. So I'm actually going to build this, and I know I'm running out of space here, but I'm going to build it up like this into a parallelogram where this distance is your 800 pounds. Now again, from honors physics, you can start building triangles kind of out this way and out this way. You can absolutely do that if you remember that. I think you guys did it in first semester. But I want to do this as though nobody's seen this problem before, so even if you're not in honors physics, you can still do these pretty easily. Okay, so again, 800 straight down the middle of my parallelogram. So now let's use a little bit of our geometry skills. Straight down means 90. 90, 35, that means 65 is left over. I'm just kind of fill in some angles here so you can see in a minute where I'm going with this one. All right, now, this 50 here, if it's a true parallelogram, should be the same over here. So now I can draw my 50 over here as well. All right, I have to complete this parallelogram. I kind of ran out of space. All right, so let's kind of go like this and the 800. Okay, that's probably the worst parallelogram I've ever drawn, but let's get the idea here. Okay, now if this is T2 over here, and it's a parallelogram, I have a T2 over here as well. Okay, so now if we can kind of focus our attention just on this green triangle that I'm building, all right, again, probably the worst one I've ever done, but there it is. All right, now I'm starting to see things labeled up pretty nicely. I have an 800 on this far side. I know now that this whole angle is 85 degrees. Okay, and then if I do a little math with the 180s, and this guy up here should be 40 degrees. Okay, so now, I know it got a little messy here, but now let's picture, what if I do law of sines? Sine, oops, of the 85-degree angle over 800 equals, let's do T1 first, sine 40 degrees over T1. Okay, then if you do your cross multiplying, I get T1 to be 512.3 pounds. Okay, now I want you to do the same idea for T2, law of sines with T2, and we'll check that answer in class tomorrow.